Hi Bobcats! In this video we're going to take a closer look at oxidizing and reducing reactions as well as oxidizing agents and reducing agents. When we're looking at a redox reaction, we typically are going to use oxidation numbers to identify what got oxidized and what got reduced, as well as to identify what is the oxidizing agent and what is the reducing agent. The key in all of this is going to be oxidation numbers. There will be other times, or there will be some times where things like looking at how the number of oxygens in a molecule changed, that also will be clues for this. But generally speaking, when we're looking at whole redox reactions, the most reliable thing that we can use is oxidation numbers. So as an example, let's look at these two reactions to see if we can decide what got oxidized and what chemical got reduced. So in this first one, as we're looking at it, there's really just two elements present, copper and silver. So one of them must have gotten oxidized, the other one must have been reduced. And the good news is, in this particular reaction, they are wearing their oxidation numbers, which makes it a little bit easier to identify. For instance, silver on the reactant side is a +1 oxidation number, and copper on the product side is a +2 oxidation number, because the charges are their oxidation numbers. The solid elemental forms, copper solid on the left-hand side, since nothing is written here, it's a 0 charge, and for silver on the product side, it's a 0 charge as well. So if we look, say, at the silver species, on the left-hand side, it's a +1, and on the right-hand side, it's a 0. So +1 going to 0, that means it's getting reduced. It's getting to a smaller number. And so the species that got reduced was silver. On the other side of this, let's switch that over to red, copper starts out with a 0 and ends up with a +2. So that means as copper goes from 0 to +2 and that oxidation number is increasing, copper is oxidized. And we can tell that in this reaction simply by looking at the oxidation numbers. Now the next reaction is a little bit more complicated. There are a lot more species here. There just seems to be a lot more going on. The good news is that one of these species is wearing its oxidation number on both sides. So if you look through this reaction, notice that on the left-hand side, we have iron ion with a +2 charge, and on the right-hand side, we have iron ion with a +3 charge. So when that +2 increases to +3, that's the thing that's going to be oxidized. Now that leaves us still several things to choose from to decide what got reduced. We've got hydrogen, oxygen, and iodine. Now hydrogen and oxygen most of the time in these reactions aren't going to be oxidized or reduced. They're going to be around in the form of an acid, which is the H+, what the H+ is indicating on the reactant side. They're going to be around in the form of water. And so usually it's not going to be these guys. If hydrogen or oxygen is being oxidized or reduced, you more than likely are going to see their elemental forms on one side or the other. You'll see H2 gas or O2 gas. That's not the case here. So it's probably going to be the iodine. And good news, the iodine over here on the product side is in its elemental form, I2 solid. So its oxidation number in this species is going to be 0. And over here on the left-hand side, iodine appears as part of the iodate ion. And overall, it has a -1 charge. The oxygens in this ion each contribute -2. There are 3 of them, which means a -6. So that tells us that the iodine over here must be a +5, so that +5 and then the -6 from the oxygens add up to give a charge of -1. So iodine is going from a +5 to a 0, which means it's being reduced. The other thing you can look at in this particular example is that on the left-hand side, the iodine has oxygens, and on the right-hand side, iodine's all by itself, so it's missing those oxygens. So that loss of oxygens also indicates a reduction. In this slide, we're going to take a look at something known as oxidizing and reducing agents. I want to diverge for just a moment and talk about a secret agent, James Bond. So James Bond is the person that the British government calls on when they just plain need to get something done. James Bond comes in and takes care of it. Well, that's what happens with oxidizing agents and reducing agents. We're going to use an oxidizing agent when we have something in our beaker that we need to get oxidized. We're going to add an oxidizing agent to make that substance get oxidized. So oxidizing agents are going to act on another chemical to oxidize that other chemical. And let's think about this for a moment. Oxidation and reduction always have to go hand in hand. So if the oxidizing agent oxidizes another chemical, the agent itself must get reduced. That's how we're actually going to typically identify oxidizing agents. The oxidizing agents are going to be the chemicals that get reduced. Some examples of things that commonly are oxidizing agents are things like oxygen and chlorine. Sodium hypochlorite, that's the active ingredient in bleach, which is a great oxidizing agent. On the lab scale, we frequently use things like the dichromate ion, Cr2O7-2, and the permanganate ion, MnO4-1. Now, everything that we just said for oxidizing agents has its corresponding component for a reducing agent. Reducing agents are what you add to your beaker when there's something in your beaker that you need to get reduced. Because the reducing agent makes the other chemical get reduced, the reducing agent actually gets oxidized. So the substance in your reaction that got oxidized is your reducing agent. Some examples of commonly used reducing agents include carbon. That's used on an industrial scale, like for smelting iron ores and reducing that to just the iron metal. Hydrogen gas is used for expensive metals where you don't want to contaminate it with the possible side reaction forming a metal carbide. Magnesium and zinc are commonly used on a lab scale as reducing. So let's revisit these reactions where we've already identified what got oxidized and what got reduced. We said that copper in this first one was oxidized and that silver was reduced. Likewise, in the second reaction, we said that the iodine here in the form of the iodate ion got reduced and the iron ion got oxidized. So now let's talk about the agents. From this information, how do we identify the oxidizing agents and the reducing agents? Well, in the first reaction, since copper got oxidized, it is filling the role of being a reducing agent. The reducing agent is the chemical that gets oxidized. Then since silver got reduced, it's serving in the role of being an oxidizing agent. So depending on what perspective you want to take, copper reacts on the silver ion to make the silver ion get reduced, or silver acts on the copper to make the copper get oxidized. In the second reaction, iodate as a reducing agent has those, iodate is the chemical that got reduced, which makes it our oxidizing agent. And then iron ion is the chemical that got oxidized, so that makes it our reducing agent. So notice how our oxidizing agent actually has some oxygens present in it, and it loses those as it gets reduced. And then here, if you want to think about the iron ion as being a reducing agent, and then the iron ion reacts on the iodate ion to make the iodate ion get reduced. Some of the applications of oxidizing agents include commonly things like disinfectants. Oxygen is a very common oxidizing agent. You use it in your body to convert the stored food into energy in your cells in a process called cellular respiration. In combustion reactions, like what happen in the internal combustion engine in a car, the oxygen helps to convert the fuel to energy that your car uses to move. There's another form of oxygen that's known as ozone, which is O3, that is used in water treatment. It's used a little bit in the United States for this purpose, but it's used extensively in Europe for water treatment. Ozone also, by some redox chemistry, helps to absorb ultraviolet light up in the stratosphere. And then some other things that are used as oxidation agents, or some other uses, are things like disinfecting, bleaches, things of that sort. Some applications of reducing agents include things like smelting metal ores. So you can take something like iron ore and reduce it to just iron metal by using something like carbon. Antioxidants are reducing agents, so things like vitamin C and then various chemical compounds that are found in things like blueberries that make them antioxidants, or even dark chocolate. And also hydrogen is used commercially as a reducing agent. So we were trying to use oxidation numbers to figure out what got oxidized and what got reduced. So if you look at the oxidation numbers for the species in your reactions, the species whose oxidation number increases from the left side to the right side is the species that got oxidized. The species that gets oxidized, by definition, is your reducing agent. And then if you have a species whose oxidation number decreases or is reduced from the left side to the right side, that makes it a reduction reaction, and whatever gets reduced by definition is your oxidizing agent.